Hey folks, in this video I would like to show you how you can use GraphQL subscriptions and also how you can make them type safe. If you hadn't had any experience with GraphQL so far, I would recommend you to check out one of the videos I linked below to get an intro into GraphQL itself. Let's talk a bit about GraphQL subscriptions. Subscriptions in GraphQL are a way to define a stream of data. So instead of querying your backend once, you open a connection, normally over WebSocket connection, that streams to you updates on the data you subscribe to. For example, if you subscribe to a list of comments on a blog post, then a subscription might, for example, be the array of all blog posts or newly added blog posts since you subscribed, and these can be sent down the WebSocket connection so that you can display to the user as soon as you have the data on the backend. In this video, we're going to take a look at how we can implement subscriptions in Apollo specifically. So this is going to be JavaScript focused, so make sure you have a bit of Node.js JavaScript background before you start. So without further ado, let's jump right into the code. As you can see in this example, GraphQL Subscriptions itself provides a way to record these updates that you want to provide, and it does that by having a PubSub library. And I would like to show you how that looks in action, and we are going to explore the problems that comes with this approach with Typescript, and we're going to move over to RxJS. So let's get started. In this example application, we are going to talk about blog posts. Blog post is going to have a title and it's going to be accessible via query, subscription, and we're going to add a blog post by our mutation. Now, as you can see in the old implementation, like our current starting point, we create a new PubSub instance, we create some data like as initial data if we want to show, and then we publish data to the event stream. In the query, we just return our local object with the initial blog post. In our mutation, we push a new blog post created by the arguments to the initial blog post array, and we also publish the update with the new blog post list. In the subscriptions, we initially, after subscribing, publish the list one time so that the first thing is emitted, you can see it. And finally, we return a async iterator on that subject for the blog post change. Let's take a look how this works in reality. First of all, let's try to build a query. For a query, we just need to write a title, blog post and title here, and we're gonna see our initial list. Oops, forgot to write the title. Here we go. Okay, so next, let's do a subscription. For a subscription, we also just need to add the blog post and the title, and the first event is emitted immediately. And lastly, our mutation for adding blog posts is going to have a title. Let's say my next blog post, and let's use the title, run it, and we see also in the subscription. Let me close that real quick. Can we see that? Yeah. You see here, there's also a second one. Awesome, it seems to work. So now let me show you how this already works with TypeScript. I won't show the types because they're just very clumsy, but I will show you and link you to the tool that actually generated them, so you can also add that to your project, because that's very neat to have really cool types generated for backends and frontends based on your GraphQL schema. That makes the whole experience really type safe, which is cool. To show you that they actually work, let's change the blog post to be something different. Let's say with a string. As you can see, the query already has a type error, which is great. Now let's change it back real quick, and let's try to do the same for our pub/sub. And oh no, we got no type error, although this is definitely wrong, and it's gonna be wrong thing in the output. And also changing it here won't affect any TypeScript errors, and that's why I would like to show you how we can remove this pub/sub library at all and get to a cool and new completely typed solution. Let's get right to it. So first of all, we need to import a behavior subject from RxJS. A behavior subject actually memorizes the last value put into the subject, and therefore is a great way to show here directly something as soon as we have an immutable value on that subject. So we won't need the channel anymore, but we will need a blog post subject. And it's gonna be the behavior subject with the initial blog post as the initial value. We can now go on and remove stuff we don't need and move the code over to use the subject. So for our mutation, we can simply push a new value into the subject via the next property. As you can see, we have some pretty cool type hints already here, that the value passed needs to be an array of elements with the title property string, and that's pretty cool. So we pass down the initial blog post and also go ahead and remove stuff. So now let's change our subscription. So the timeout we don't need anymore because our subject is going to emit directly. And first of all, we're going to import a helper I'm going to show you in a second, which brings our observable to a async iterable, which is the thing that we return in the end. Sorry, async iterator, of course. And we just wrap it here. And that's gonna be it. At least if the subscriptions don't require us to wrap everything in this blog posts here. That's kind of the convention that we have. So it's complaining that we don't have the blog posts in this type, but directly the array. Let's fix this by mapping our observable. Now one last import is missing for the map operator, and that should be it. And we see it still complains. Let's take a look. It seems like our underlying types are wrong, and instead of an array they expect us to have a blog post directly. We wouldn't have had a chance to find this bug before. Great. Let's go ahead and fix it. Here in the subscription resolver, it seems like we have a blog post instead of a blog post array. So let's fix it. And let's check the server again. And no more Typescript error, great. The last errors that we have here come from us having old imports, so let's go ahead and remove them through the entire system. You don't need to pass in the library as a context anymore, so this can go, and that should be it. Ah yeah, and the import needs to go as well. So now let's take a look. Seems to be starting. Let's give it a chance to reboot. Oh, there was it almost. And here we go. So let's first take a look at the subscription. Looks just fine. Let's make this a bit bigger right here. Awesome. And now let's add a blog post again as we did before, and we see we got a second event and our refactoring worked just fine. Great. Let me show you where all the magic happens. It's gonna be our cool observable to iterator file, which is going to be an open source library soon, as soon as I have time to publish it. I will link it in the comments. So let's take a look. We got a little helper over here, which iterates a result. So it takes a value and gives us a result. And down here comes the real implementation. So the idea is we take an observable of the type T and return async iterator of the type T. Simple as that. If you think about observables and iterators in a conceptual way, there are two different ways of resembling the same concept of streams. So an observable is something that you can subscribe to get updates on the stream of information you're interested at as soon as the stream gets to create this information, as soon as some new event happens. A async iterator is the opposite of that. Instead of being notified about changes, the iterator tells the stream or the producer of the information that it is now ready to digest a new set of information and can work with that. So it's a pull-based approach versus a push-based approach here. And we're going to convert one into the other. For that, we need two types of queues, a pull queue and a push queue. Our pull queue is going to store iterator results if the observable emits faster than the iterator consumes things. Our push queue is going to store promise resolves, so that if our iterator asks for more things than our observable can emit yet, it's going to be stored there and these promises are going to be resolved. So as you can see, we subscribe to the observable being passed in, and on next, so if an event is emitted, we take a look if something's in the push queue. If something's in the push queue, we can directly resolve this promise that's stored there. We're going to see later how it comes into place. And if there's nothing in the push queue, we are going to add something to our pull queue. Then we have a bit of code for errors. So if there's an error, this means in the RxJS world that the observable completes and nothing else going to be emitted on the observable. So what we do is we take the quickest route to clearing both the pull and push queue so that we don't have a memory leak, and we just throw the error, which is the way how async iterators handle error cases. On complete, so if the observable finishes, we check if something is still in the push queue. If there is, we're going to resolve that one last promise with a done true, and if not, we're going to add a done true to the pull queue so that when the iterator asks for the next thing, it's going to be clear that it's done now. So let's take a look at what we return. If the iterator asks for the next element to get, which is the next call we see here, We first see if we have something in our pull queue which we can draw from. If so, we just resolve a promise directly with this item we have there and be done with it. If it's not the case, we return a new promise and the resolve function we pass in our push queue. And that's basically it for next. On return, which is our completion event on the async iterator, we unsubscribe from our subscription so that we don't use the observable anymore and resolve a promise with done true. Unfortunately, we have to add a TS ignore here because some types didn't line up or were incorrect. But hey, that's life. And last but not least, we needed to have the async iterator down here, which returns this, because that's how JavaScript knows that we are actually working with a async iterator here. So to summarize, by ditching pubsub and using observables instead, we get a fully typed interface from our GraphQL onto our resolvers, which enables us to not do errors there and to really understand the code better. I personally see that pubsub could make some sense if you work with distributed systems. So if pubsub is being hooked up to, let's say, RabbitMQ or Redis or something, and for these cases there are pre-made adapters already there, it could totally make sense to use pubsub as it's an out-of-the-box solution. But in my opinion, it's also pretty easy to wrap the consumer here, the producer here, so your Redis instance or your RabbitMQ client into RxJS and to just use it like we shown here. I hope you enjoyed this video. I had a lot of fun creating it, and if you are interested in some more topics, please let me know in the comments.